Okay, so we're going to find the particular solution that satisfies the DE and initial condition Okay, your differential equation is f prime of x equal to negative x squared plus 7. And the initial condition is f of 0 equal to 0. And I wrote out steps to do this. The first step is to integrate the DE and get a general solution. Okay, the integral of negative x squared plus 7 with respect to x. Someone want to tell me the answer? Type the answer. Well, it's difficult to type. So negative x cubed over 3 of 7x add c. So when you don't know what c is yet, this is a general solution. Okay, use your initial condition. Well, we're going to put it into the general solution. So sub in 0 for x. And then sub in f of 0 equal to 0. So this is going to be replaced with 0. And we're just going to start working on simplifying this side. Right, this is going to be 0. Okay. We need to finish by just writing up our answer. Negative 1/3 x cubed plus 7x plus 0. Okay, let's do another one of these. Okay, this time your differential equation is the derivative, f prime of x equal to 1 over x squared. Initial condition, f of 1 equals 4. Okay, so first, integrate the DE. Okay, here's 1 over x squared dx. Let's rewrite this. And then use a rule. Add 1 to the power. That also goes in the denominator. Plus c. Okay, don't forget the next one. Add c. Next, we're going to use the initial condition to get c. We know 1 equals 4. So we'll put in 1 for x. 1 over 1 plus c. And then we'll put in f of 1, which is 4. Or substitute f of 1 with 4. Solve for c. And then write your answer. I've got another one of these, and then we're doing word problems. Okay. Your DE is, I've got -2 sine of x. And f of 0 equal to 8. And we go through the steps. First step, integrate the DE. Okay, so we're gonna have, oh, I'm missing a negative sign. My negative sign was supposed to be there. So it's gonna be a -2 times negative cosine. Make sure I get this right. Let me see. Yeah, -2, negative cosine x, add c. Cosine of x plus c. And then apply the initial condition. F of 0 equals 8. Okay, so first we'll put in x equal to 0, and then we'll put in f of 0, which equals 8. F of 0 is cosine of 0 plus c. Oh, I missed a 2 right there. That's better. 2 times cosine of 0. Add some number that we're going to find in just a sec. Replace f of 0 with 8. Simplify cosine of 0. It's going to be 1. Solve for c, so subtract 2 from both sides, and 6 equals c. Then you write your answer. That's the, I like to, you're doing online homework, but for me, I like to kind of like highlight this. Yay, we're done. Okay, so I've got a little bit, oh nice. Thanks for the comments, you guys. And thanks for saying that I missed a -2. All right, any questions or did I make any mistakes? I think we understand. Seems like we understand. So I've got some help for the word problems, and then we might do more word problems next time. The first one is about a canyon. Sorry, let me see. I'm gonna go full screen. Cool. I'm also gonna hide you guys just for a bit. I can focus. Still getting used to Zoom, but let's do this. A canyon is 4,500 feet deep. A rock is dropped from the top of the canyon. We're going to use acceleration. Oh, I have. Oosh. I'll put this little side note up in a second. Finishing this problem. Use acceleration equal to -32 feet per second squared. Okay. As acceleration due to gravity. Okay. Then the goal is to express the height of the rock as a function of time t. The height in feet as a function of time in seconds. So your height function is going to be called s instead of f. So s is your function as a function of time t. S, height in feet. Okay, so I wanted to introduce position, velocity, and acceleration. And then we'll get back to this problem. First. So sorry for kind of jumping to the side, but side note. Given a position function, after t units of time, all right, you've got your position function, so s of t equals position or height in feet. Take the derivative of that, and it's velocity, so s prime of t, your velocity function. Feet per second. And then take another derivative. Oh yeah, you guys have seen this if you've taken a physics class. Second derivative will give you acceleration. Per second squared. Okay. This function is sometimes called v of t. And the acceleration function can be called a of t. I think that's everything. So back to our problem. We had acceleration negative 32 feet per second squared. And then I'm going to just kind of write up some more scratch work for that word problem we started. Okay, so I've got some initial conditions. Okay, so there's not a lot going on, but I'm kind of a visual person, so I did draw a little picture. I had this person on top of a canyon. They have a rock in their hand. They're just going to let the rock go. I'm just going to drop to the bottom. And then it goes down 4,500 feet. Okay, I put t equal to 0 as the initial time. Okay, the initial height will be s of 0. And it starts at a height of 4,500 feet. Okay, cool. Yeah, and then pictures do help, I think. Initial velocity, so it's just dropped, not thrown down, or it's just let go of. So the initial velocity is 0. The rock is dropped. See that right? Let me see. Okay, I think that's all of my initial conditions. And then I took the, yes. The acceleration that they gave us was negative 32 feet per second squared. Then we start doing some work. So I've got that we want to take the integral of s double prime of t, and that'll give us a function for s prime of t. Negative 32t plus c. You take something from your initial condition to figure out what c is. S prime of 0 equals 0. So first I'm going to put in 0 for t and get out negative 32 times 0 plus c. And you know what s prime of 0 is? It was 0. So substitute this in right there. And then simplify that side, which is going to leave c. All right, so s prime of t is negative 32t. Okay, so we're going to go through this again. Oh, there's a chat going on. I'm going to catch up with you guys really quickly. Oh, you're having a... Okay, sorry, I'm just like seeing what you guys are talking about. I will try to write bigger. I can't really, I don't know if I can make the video quality better. But we'll try to make it so this is easier to read. All right, we need to find this function s of t. So let's integrate this, apply initial condition, and I think we're done. Okay, the integral of negative 32t dt. So we want to have this power 1 add to that and then divide by that number. This might be a different number C, so I'm going to make it look a little different with subscript. Let's put little subscript 1. So we'll solve for C1 using initial conditions. Sorry, I just want to check on you guys. So, having a hard time seeing the screen. Let me see. Someone else commented on that. Exit full screen. It's fine. Okay. All right. Well, let me know. You can check on my Zoom settings. So we have plus some number. We called it C1. We know we want to apply initial condition. S of 0 was equal to, let me see. S of 0 was equal to 4,500. We'll put 0 into the function. And then we'll put in the value for S of 0 as 4,500 right here. And we're going to go ahead and simplify this side. 0 squared is 0 times some number is still 0. And so the value for C1 is 4,500. And we finally have an answer. So the function for height is S of t. And, oh, sorry. The internet? Okay, let me go mess with my internet really fast. Oof. Let me write the answer. Okay, sometimes that helps, but I don't know. Okay, we want to do some more on this problem. The next part, part B. Is how long will it take for the rock to hit the canyon floor? Okay, so I put since S of t is a function the height of the rock. We want it to hit the floor, so we want that height to be 0. We want S of t equal to 0. We want the value for t, let me see. Yeah, we want the value for t when S of t equals 0. Maybe we'll draw a picture again. Maybe just feet. So again, I'm just going to say that a height of 0 feet is the part of hitting the canyon floor, getting all the way to the bottom. Okay, so this is what we want. We want 0 for S of t, and then we're going to solve for t. I'm going to add 16t squared. Divide by 16. Square root both sides. Don't forget the plus or minus. Okay, and this value for time is going to be a positive number. You don't want a negative number for time, so positive of this root. I got 16.77. seconds. Okay, just as a little side note that we chose a positive number because time cannot be a negative number. One more word problem, if there's time. All right, on the side, I've got a general position function for a falling object. Is S of t equal to negative 16t squared, or half of the acceleration, negative 1/2 of the acceleration times t squared, add v naught t and then add S naught. Okay, so S of t is height. T is time in seconds. All right, last example. So, with what initial velocity must an object be thrown upward from a height of 2 feet to reach a height of 200 feet? All right, what initial velocity? From 2 feet. Okay, let's draw a picture. So this time t. I'm gonna have my person. Well, I guess it's probably not a person, but anyway, there's this ball that's going to be thrown upwards and then it comes down. From 2 feet to 200 feet. Okay, and then we start solving the problem. I've got some initial conditions. The acceleration will be negative 32. Feet per second squared. The initial height is S naught, which is 2 feet. And let's see, we want to find some value for t that corresponds to a height of 200. So some value t right here. All right. I put first substitute in to the formula that we have. S naught and let's see. Sub. You know what S naught is? It's 2. We're going to figure out V naught. We also want to know T, and S of T equals 200. So we can put in 200 right here. Okay, and I just put a little bit of work and then a note. So let's work this out just a bit. Subtract 2 from both sides. And then I put a star here. Oh, I should have saved my picture. Well, let's draw this again. So we have a 2 to 200. Between 2 and 200, a ball is traveling up. And then back down. We're looking at some t value. Corresponds to S of t being 200. And let's see, the slope of the tangent line right here, when you reach that final height, would equal S prime of t. And also we want that slope to equal 0 when it gets to the final height. So I just put, to find t, use S prime of t equal to 0. Okay. In the velocity function, which we need to find. Okay. The integral of S of t. Or wait. No, we're just taking a derivative. Okay, we have that function S of t. Take the derivative of it to get negative 32t added b naught. And again, we're using this part here, so 0 for S prime of t. Solve for v naught. Or no, I got solve for t. Gotta get used to these. All right, solve for t. So to add 32t. All right, almost there. So I put substitute t, this t value, into this equation that we've got. And what will be left is that velocity we're looking for. So substitute into. Okay, so we're just working through until we isolate V naught. So 198 equal to negative 16 times V naught squared over 32 squared add V naught squared over 32. Eesh. Okay. Get this clean. So what I did is multiply this by 32 over 32, which is fancy number 1. So I got that common denominator, just put the numerator over 32 squared. This is going to be a numerator of 16 V naught squared, and then I'll multiply both sides by this 32 squared. Divide both sides by 16. And then square root both sides. There is a plus or minus sign, but we're going to have a positive velocity. Work. See, I put this part, that part. Square root it. So I guess I'm just going to erase the minus sign. So like I said, velocity will be a positive number. And what I got in the calculator was 112.57. Feet per second. This would be, let me see, velocity is in feet per second. Ooh, we gotta go. So that's it for today. We are probably gonna do another example or two for 6.1, and we'll start doing U subs in 6.2. Okay, so I need to